Hi everybody, I'm back again with another project in machine learning technology in the business domain of real estate. This project is all about the resale flat price prediction. In Singapore, it seems to be very difficult to predict the price of the apartments. Yeah, this is the predict page where we have all these 11 sets of parameters which we have used for the machine learning. Whereas, I've used two different data frames, one with all the features with the names, whereas I can easily load the same with for the user interfaces. Whereas for machine learning training and all, a different data frame is used, which where generally all the labels were encoded with the numerical values, where we won't be able to see the names of the towns or streets or flat types or anything. Like everything is categorized into numerical. So that data I've kept it for training the model, whereas this particular data I've used it for the user interfaces and for filtering purposes. This particular data will get fed to run the prediction. Here we start with the towns. Like we have all the range of 27 towns over here, where we can select some particular town, and based on a particular town, the street will get selected, which is very much related with that particular town. And based on the town and the street, especially the street, the types of apartments also will get shortlisted. I mean, like it will get narrowed down. Whichever is there, only that will get what is there, that will be shown over here. So, there is no point in predicting the type of flat which is not existing there. To make the prediction a little truthful, so I believe that this kind of filter will help a lot. And even the model types also will get filtered. It is exactly based on the data, like whatever the data we got it through the source of from the Singapore government resource, whichever is there meant for this particular type of room, that particular type of model will get narrowed down. So we can choose that with the stories, whatever the stories. I mean, this is the floor, the number of floors based on the apartments. We can shortlist to the number of floors, and here comes the area, the square area. We can choose based on our the requirement. And here comes the resale year, where we can even check with the past also based on the records. But I've observed that it won't be so exact. Like it will be kind of a mean, a very median value from what the factual data is. Then we'll go with this the resale month, the number of years lease left out. More the year, it'll get a particular value will get add on to. If the lease period is there, or if the lease period is very lesser, then the predicted price also will be little lesser. And this is the average CBD distance, the center of business development. It's a major place where that is the work hub or something, like where from that distance how the property is located, where it is located, and based on those things, and the average distance of the MRTS distance. Why it is average? Because like we are not specifying any pinpoint address over here, where we are searching with a particular street, where in a street there are so many blocks, and every single block will have a little of differences in those things. Whereas like when we are generalizing it to a particular street, where the average of these distances have been taken into account. Once we set the parameters, then we can go for the predict. It'll take a little time. Now the predicted price is shown over here, and this is the price in the Singaporean dollars. So this is all about the prediction part, which is a very general thing, like where most of the people just restrict themselves with these kind of features. But I've added something extra to this project, that is analyze section, where in this analyze section we are going to see the price patterns over the period of time, like from the a specific period of time, like say we'll check with the thing with the particular. So I'll go with second Rivervale Street, and here with, yeah, I've observed some big changes in this particular area. That's the reason why I'm choosing this especially. Now when we have chosen all the cities and the towns of the city and the specific streets, now we go with the time intervals, like when the time interval is, when the value over here is more, the computational task is lesser. As you can see that when it is 6, it is only the 18 decision tree regressor calculations, whereas when we increase it to, it becomes more. So first let us check with the 6. So it will take a little time because 18 regressions has to happen, but still this is the very quickest. This is what it is. So we see the deviations in the prices where these 3 towns, they were colored to the corresponding, they were colored in such a way to get identified. So it is the town 1 is blue and the town 2 is green and town 3 is red. So like here also we can see the legends. This is where the price is dropped in Bishan, a particular street, and whereas here the Queenstown price is dropped in the time of 2015. Probably there could be some reasons actually, like, and we cannot just check with this, and we cannot just, this doesn't give a very clear idea about, like, because we have chosen the very a very less intervals, like it has got only the 6 intervals, as it says 6 over here, it is a 6 interval thing. Let's go with much more. When this comes to, whereas like when the graph is generated, it's dealing with 51 tree regression calculations, obviously, which will take much more time compared to the previous one. So generally I'll speed up in a time lapse where these the processing will go a little faster to reduce the time span of the video. See, here we see the very detailed deviations in the line graph, the line chart. See here the Bishan is dropped down to the other things. Let us see, like, the auto scaling is happening. So the price drop at those points and the price hikes in few points. I see second is little expensive. So in a recent period of times, but again, like every in 2002, maybe everything is altogether down, but I don't know the reason. Like, so this is all about the analyze part, where we can even go in a very detailed analysis with so many time intervals. So we can see every single time, every single change in the chart in terms of time. It'll take a little time, a little more than the previous one, as the steps involved in this is 102. That is 34 into 3, 34 time intervals throughout. Yeah, we got the result. And this is what it is all about, like with a very detailed, with so much of year on year intervals. I think it is, yeah, see, like you see the intervals based on the year by year, and this is the corresponding chart. Basically, the chart will be so same, whereas only the graph will change based on this. The chart is always with 33. This is all about the application. As they say, like this project is used to predict the prices in Singapore. The prices varies based on the various factors such as the location, the apartment type, floor type, the lease duration, the distance from the major landmark and facilities. This particular tool is a kind of an experimental tool, the domain of real estate, where while doing this particular project, I've gone through the responsibilities like the process in the machine learning pipelines like data wrangling, data processing, data visualization, feature engineering, ML parameter tuning. Model parameter tuning is a very difficult thing, I believe. Like it's kind of for attaining the accuracy, it took so much time. Like first, I thought like I can do it automatically with hyperparameter tuning, but 20 hours, and the result was not there. And the technical description deals with the libraries, what are all the libraries used in this project, and what is the purpose. Like basically, like what it is designed for, and how I've made use in the project. And these are the processed data for the machine learning. Like I've used a Jupyter Notebook in Visual Source Code, VS Code, where like the lot of process it got involved with the data cleaning and data wrangling, and some two of the features were being engineered through the external resources, like based on the MRT stations locations, where I used a GeoPy module for getting the latitudes and longitudes of the places, and even the same thing was used on the address column of the property, and I was able to get the latitudes and longitudes by comparing the distances. We got the distance, like the distance from the Center of Business Development, that CBT, and MRT, the Mass Rapid Transit. railway system and their distances from the apartment, as it's an amenity, like it also influences the price factor. And this is all about like where the source, where I source the data from. And this is a chart which generally says like which generally describes the score of every single model. Like I put these many models into use with their own parameter tuning to check for the accuracy. I'm lucky enough to get the best accuracy, more than 98%. Like most of the models, they showcase 98% of the accuracy. XGB regressor, extra gradient boost regressor, is the one which tops with 0.9868 and some decimals. So here we can see the scores when compared to everything. Like here it says, and XGB regressor contain maximum R2 score like 0.9868, 480. It goes on like this point, this much of point precision. It won over the other regressors. Like the next best is the random forest, which is 9850, and the later comes the decision tree. Here in this, for the predict, I've used extra gradient boost regressor, whereas for the analyze, I've used the decision tree regressor, as it's fast, very pretty fast compared to any other. And this is the feature comparison chart where the feature prominence, it's a funnel chart. It is all about like what are the features very prominent here. This is the Jupyter notebook. old fashioned one. Then we are checking the model code and this particular build some houses where we are already seeing that the few features were being added at a distance of 1 or 2 years into seeing this is the main thing is there as a CSV. I'm checking it out. This house is located in prospective, which is related to the other part. When we select Streamlit, as per the when we select midterm, sorry, when we select the town, this particular location only the dependent selectors has to get selected. For that reason, like I have taken this predicting. Then we are checking for the unique town names. Here, one thing we are going to complexities. Complexities is the numerical tagline for this product. So Resale Prices Predicting, predicting, sorry. Similarly, same thing is done to the street name also. This for the floor also same concept, same thing. This is where this is like this is the main where main numbers numbers which we are entering which we are selecting. There are parallel areas being created where the lease activities were done from the sourcing from this particular, like we are taking the list of all the metro stations, MRTS stations, sorry, MRTS stations of Singapore, where the stations were very much in scope, which is surrounded within the residential areas where the actual scope of activity is not clear because it takes so much time to extract all the latitudes and longitudes using the geofile. So I'll just come to and as we see this house is in the this area is in the industrial Here we see the deployed version of the same project in the render. So it's a little bit slow compared to the local machine. Let us just check. Local is the difference, but so when I do the selections like this, so this is how it is. It will take a little time to connect with, but I don't know whether I'm having such issues or it's generally like this. Again, it's running. Let us see the predictions. So we got the predictions here. So it is taking a little more time compared to, because in the free plan probably the CPU is allocated is very lesser when compared to, I don't know exactly what is happening. The only thing is like it is not in the local host. That way we see it is very different. Connection